Okay, here's the calculator portion. So again, try to go kind of quick. These aren't going to match yours perfectly. The numbers might be a little different, but they do help. It says use the appropriate compound interest formula. So we're going to invest 26,000, 3.65 for 5 years. So we're going to do it. I'll just do my calculator screen here. So let's see. So if it's for part A, if it's daily, I would take 26,000, 1 plus, and then it'd be 0.0365 divided by, and if this is daily, it'd be 365. I'm going to raise that to the, and if you have an older calculator, put this in parentheses. If you have a new one, it's okay. So 365 times 5 years. So you should get 31,205.2. And then if I'm going to do this continuously, the only difference is when I put in the calculator, instead of using 1 plus, I'm going to go use e. So it would be e to the, and again, 0.0365 times 5 years. So this is 31,205.56. So it's just a little bit more, and that makes sense, because compounding continuously is not going to be, I mean, it's going to be fast, but not a whole lot faster than daily, so you're going to get just a little bit more in the end, so, but not a significant difference in the amount of money. Write the equation in its equivalent logarithmic form. So log, the base is 7, the answer is 116 equals the exponent x. Okay, so that would be, let me get the right one here, log base 7, so what's that, A? Number 3, the amount A. So we have 300 grams of a certain radioactive material for this. When will this remain? So I might write my work up here just to give a little bit more room. So I want to do 180 equals 300 times 0.75 to the t. So we're going to have to use a logarithm to solve this. I'm going to divide that over first. So I'm going to have 180 divided by 300. So this would be 0.6 equals 0.75 to the t. I'm going to log both sides and eventually divide by log 0.75. So I'm going to do log 0.6, close parenthesis, divided by log 0.75. And that give me 1.78. It rounds to the nearest, so 1.78. Solve the equation. So this guy, let's see here, it says if we're going to solve and the variable is in the base like that, it's saying x to the 4th power equals 16. So if it's not that the variable is in the exponent, I don't need to use logarithms, I'm just going to take the 4th root of both sides. Okay, so this one's going to be 2. And if you weren't quite sure what to do, you could just look at your possible answers and plug them in until one works. You know, take 2 to the 4th power, take 64 to the 4th power, and so on. Number 5. So to solve this guy, we're going to get the exact answer and then get the let's see, the exact answer and the approximate answer. So first off, divide 5 over. So I got e to the 4x. If I divide by that 5 or by 5, it'd be 300. And I could use a log for both sides, but since this is base e, a natural log is going to be faster. Okay, so natural log of e is gone, so it's going to be, pull the 4x out front, so 4x equals a natural log of 300, and then divide that by 4. So that's the exact answer, natural log of 300 divided by 4. And then if you put it in your calculator, you get 1.43. 1.43 for that one. Number 6, solve the logarithm equation. Be sure to reject any extraneous values. So on this guy, log base 4, that means I can write 1 log base 4. Since this is plus, I could multiply them. So it'd be x squared, it'd be minus 2x plus 4x, so plus 2x, and then minus 8 equals 2. Get rid of that by taking 4 to both sides. So x squared plus 2x minus 8 would equal 16. Bring the 16 over. So it would be what? Minus 24 equals 0. Try to factor first. Let's see, factors of 24. 6 and 4, right? So plus 6 minus 4. That means x equals negative 6 and positive 4. Being negative doesn't make it bad. It's when I plug it in, if it makes the argument negative, it's bad. So if I plug negative 6 in, negative 6 plus 4 is negative 2, that makes the argument bad. Plug in 4, 4 plus 4 is 8, that's positive. 4 minus 2 is 2, that's positive, so 4 works. So the 4 works, the negative 6 did not. Number 7. So it's a graph this guy, state the domain and range and all that good stuff. So I got 1/3 raised to the x power. Let's see here. So the initial amount is 1. The initial amount is 1 here. So whichever, if any of these have a 1 for a y-intercept, it's good. So I can throw out b, and I could throw out d, because this should be a 1. Now, every step over is going to be a little bit less, because I'm going to take 1/3 of that. So if I start at 1, I go over, I should be down at 1/3. So A is out. So really C is the one that could be the right graph. I got to assume that domain, range, and everything else is right. So I'm going to go with C on that one. Number 8. A town gets smaller, the population decreases 4% per year. How long until it's 100? So there's 160. It decreases 4 per year, so that'd be 96. And then how long until it equals 100? Okay, so same idea. I'm going to divide by 160 first. Same idea as on the front side here. So 100 divided by 160. I get 0.625 equals 0.96 to the x. Log both sides. Pull the x out front. Divide by log 0.96. They don't want an exact answer. Yeah, so this one's okay. We don't need an exact answer. So log 0.625 divided by log 0.96. I get 11.51. So 11. Let's see. I guess I should have wrote this in here. Made that an n. So it should have been 100 equals 160. 0.96 to the n, and now n equals 11.51. Number 9, rewrite the power and product, or using the power and product rules. So we're trying to expand this guy. So first off, that 3 is only on the z, so I don't want to pull a 3 out front yet. I'll do log base b of y plus log base b of z cubed, but then pull the 3 out front here like that. So that'd give me letter C. Number 10, Paul invests $3,000 in a savings account, 7% annually. How long until it's from $3,000 to $57,000? So we really don't need this. They give you that, but since it's annually, you don't need to divide by n because n is 1. But we're starting at 3,000, going up to 5,700, 1.07, and then t. So I'm going to divide by 3,000. So over so you can see. So 5,700 divided by 3,000. So it'd be 1.9 equals 1.07 to the t. Log both sides, divide by log 107. So log 1.9 divided by log 1.07. And I get 9.48 from the nearest 100th place add needed. I got 9.49. 9.49, so 9.49. I did not write that right. 9.49. 9.49. So, yeah, look at my calculator, don't look at what I wrote. Number 11, so we're almost there. Number 11, solve this guy. So, again, I'm going to use a log. I'm going to log both sides. So log 3 of x plus 3 equals log 341. Pull the x plus 3 out front, and then divide by log 3. And eventually, if I want the exact answer, I'm going to subtract 3 from this. So type all this into the calculator and subtract 3 at the end, and you get 2.308. And number 12, the half-life of caffeine is 6 hours. You put 110 in somebody's bloodstream. times 0.5 to the, for 21 hours, but every 6 hours is the half-life, so I'm going to divide by 6. Type this into the calculator. There's approximately 9.72 milligrams left. Okay. So hopefully this helps some. I apologize if yours was out of order, then I assume that they would stay in order. I clicked do not shuffle for the students, but we'll see. So you can always fast forward through and try to find your question if you have one.